Okay. In lab 3, you're going to be looking at the electrostatic or Coulomb's force between two charged objects. So we have two metal spheres here that are going to be charged. And we have a force meter down here on the bottom that's measuring forces. And then you're going to use a ruler to measure the distance. So what I'm going to do is make sure that I'm doing I'm using the positive and positive trial. So you could change if you don't have it automatically there. You just click on change and choose it. And then what I did is I fast forwarded through all of the charging this until it gets to 0.0025, okay? And then I kind of stepped it up. Okay, that's good. So I went to 0.2, sorry. So what I want to do here is I want to get, all right. I want to do maybe advance to where it reads 0.0029. Okay, then I'm going to turn on my ruler. And I'm going to position this so that the 0 is right in line with the white mark on the silver sphere. And that's going to allow me to measure the distance between the white marks on each sphere. So right now, at 36 centimeters, and we want to change that to meters, so divide that by 100, so 0.36 meters, there is a force of 0.0029. And then I'm just going to play this video until I want to get a total of 10 points. So now I'm at a distance of, looks like 28 centimeters, and it's 0.0034. So I'm at 28, so 0.28 meters, and I'm at 0.0034. So I'm just going to continue until I want a total of 10 points. I want a total of 10 points. So you want to make sure that you insert enough of these that you have 10 whole points, okay? And what you'll notice is that there's a column that's already calculated for you there, and that's fine. We'll talk about that in a minute. All right. So when you get your final results, you're going to want to make a graph of force on the y and distance on the x. And so if we look at our formula, the formula for Coulomb's law is F equals a constant K times Q1 and Q2, all divided by the distance squared. So if I were to just plot the force versus the distance, I should get an inverse square relationship. So this is tricky here. Some of you guys just choose, when you do your curve fit, you choose the wrong curve fit. You want to click on curve fit, and then you want to go to the inverse square, not the inverse, but the inverse square. Press done. And you'll see that it fits very, very well. The RMSE is 0. Okay. So yes, this is a good fit. It looks like it's a good fit. But to verify that, you are going to linearize this. And that means that you're going to plot, instead of distance, you're going to take 1 over distance squared and see if that's a direct relationship with force. So to do that, you're going to plot force on the x-axis and 1 over d squared. And when you get that, that should be a linear. So it looks linear. Let's insert a linear fit. And it is linear. And the R is 0.99, which is close to 1. It should be. And RMSE is close to 0, which it should be. So, yes, this is a very good fit. As long as the RMSE is close to 0 and the R is close to 1, that means most of the points are following on it like it's supposed to. So, yes, force is inversely related to distance squared. So, you're going to be using that information just to verify that relationship. I'm going to look for two different graphs. I'm going to look for the inverse square graph. It should be titled force versus distance. And I'm going to look at the force versus 1 over d squared graph. And it should be a line and it should be linear. So for both of these, you need to insert the proper curve fit and then utilize this information to verify that the electrostatic force of repulsion between those two positively charged objects is indeed inversely related to the distance between them squared.